four of us who work full time on CoCalc are all going to give short presentations for the next few minutes. And Blake will give the first one, and then I'll talk for a couple of minutes. And then Harold Schilly will talk for a couple of minutes, and then Hal will talk for a couple of minutes. So Blake, if you want to share your screen.
Sweet. So I am a little bit new on the scene. So for those of you that don't know me, my name is Blake Bejarano, and I am the Chief of Sales at CoCalc. And I'm sure that many of you are familiar with William Stein. And for those of you who are not, William's the founder and creator of the open source mathematical software Sage Math. And okay, I'm on my way. Okay, so William's the founder and creator of the open source mathematical software Sage Math, and he's also the creator of the web-based collaborative computational and data science tool CoCalc. Throughout his extensive experience in academia, William's been a champion for the unification of the mathematical and scientific computational communities through open source projects, and this ultimately is what culminated in Sage Math and later CoCalc. So if you're unfamiliar with CoCalc, it's a virtual online workspace for collaboratively performing calculations while carrying out research, teaching, or authoring and publishing documents. Our mission is to redefine collaboration in science, engineering, and mathematics by providing easily accessible and sustainably supported tools for the previously mentioned tasks and enabling a higher level of collaboration between students, colleagues, and researchers. So CoCalc was founded on the basis of removing some of the installation issues that are associated with open source softwares and making it more available. So that's good for all of us. And there's a very strong commitment from CoCalc to give back to the open source ecosystem and the community at large. So maybe at this point you're asking yourself, well, who is it that can use CoCalc? And I would have to argue, I think just about anybody could use CoCalc. And that's actually one of the things that I find fairly hard about giving a pitch, because it's like, what do you do? And it's just such a robust platform that, it really has something to offer for everyone. So again, CoCalc can be used by individuals, institutions, and corporations. In fact, anyone that wishes to actively collaborate while coding with their fellow researchers or students, or working on documents for publication, or organizing and managing projects in courses can use CoCalc, and it's great for all of those things. As the way that we engage with others around the globe, this last couple of years has been weird, I think, for everyone. And just being able to have a way that we can connect with each other online and be able to collaborate and continue our progress in the scientific and research communities is a huge win. And I think that our goal here today is ultimately to illuminate some of the various ways that Sage Math can be used in CoCalc. So that's what we're going to be doing for the next few minutes. Each of us will be giving a little lightning talk on a various way to use CoCalc in Sage Math within CoCalc. So to get us started, I'm going to briefly talk about Sagetech, which is, again, a package that allows you to run Sage code within our favorite publishing language, LaTeX. We'll go ahead and get started with that. And then after, I'll give a really brief look at some NB grader for a Sage notebook. Okay, so we'll go ahead and give this a quick look. So here I created a LaTeX document, and I went ahead and implemented some inline codes. So again, I'm sure many of you are familiar with this, but this is one asset that you can be using Sage Math within CoCalc, and you can essentially, within your LaTeX document, I want to say, okay, I have some sine function and I want to evaluate it at pi/4. So I can actually use the \sage and make the computation in it. And as you can see directly, it outputs square root of 2/2, right? So again, just some basic unit circle stuff. And we can also do things with partitions. So we can say, okay, \sage number of partitions for 6, and it'll output the number here 11 partitions for the number 6. So that's one way that you can use Sage Math within LaTeX is doing some inline coding. You can also use the Sage command line. So by using begin Sage command line, you can again use Sage and then be able to put in any kind of commands that you want. Here was just a brief example of, again, the partitions, the cardinality of partitions for the number 6, which again is 11, and partitions, a list of each of the partitions for that number, which again outputs here. So that's all 11 of the partitions for the number 6. And then you can, of course, use functions and assign a function. So here I made a really neat function that you'll see here shortly that I'll use in the plot. So I'll go ahead and scroll down a little bit. So here's Sageblock, and Sageblock is basically used to be able to show the code that you're actually using within the LaTeX document. Again, this is something that is practical for those of you that are in computational mathematics or in computer science. So if you want to share some code inside of your publication, you can use Sageblock within CoCalc in order to show some of that code. So again, here is that code. This is actually something that I just made to quickly output all of the 15-degree increments of the unit circle. So, and that actually is where we lead to here. So this is Sage Silent, and essentially what Sage Silent does is that it omits the code and just gives the output. So again, I included the code here under Sageblock, and then I used Sage Silent just to give the output itself, which in both of the columns is the X and Y values for the 15-degree increments of the unit circle. So again, Sage Silent is a good way to be able to output some code without necessarily having all of the cumbersome, like the actual code that's associated with the output. Lastly, Sage Plot. So this is that neat function that I briefly mentioned. So here I used Sageblock just to give an example of how it is that I implemented the code. And here is that function, and you go ahead and just use Sageplot, right? So \sageplot, and then you can plot that function f that I had created. And then lastly, I have a little 3D plot that I had also created. And again, using Sageplot with plot 3D with some function f that I had created here, okay? So again, CoCalc's perfect for being able to use Sagetech and be able to make a LaTeX document that has some kind of output from Sage. That's my brief little lightning talk on that. I'm sure many of you are probably familiar with this, but it's important to know that these are tools that we have available, and if you're making any kind of publications or documents, that this is something that you have at your disposal when you're using CoCalc. We'll go ahead and move over to an assignment using NBGrader. So here's an assignment using NBGrader. And for those of you that are unfamiliar with NBGrader, there are different kinds of cell types that you can use, such as read-only. So again, this is a demo assignment for the Sage Days conference today. So if I was to generate a student version of this, they would not be able to manipulate or do anything to this portion of the code. And here I went ahead and implemented a determinant of a matrix using Sage Math. So here I went ahead and set the matrix, which has these various components. And then I went ahead and just ran m.determinant, and it gives me this output. So this is something that would be an automatically graded answer. So this is another example of a cell that you'd be able to use that students in the student generated version would have to actually just put in this m determinant and make sure that they're using the right command. And then they'd be able to check their output. And then here I have a instructor test. So there are hidden instructor tests that are only available to the instructors of a course that are using our course management system, which is a fantastic way to use CoCalc. So here we have a really brief way of being able to determine whether or not these two things are in fact equal, which is the assert equal command. I have that the m.determinant command is equal to this, which it in fact is. That was my output. So if I was to run this, it would have no problems and it would not give me an error. Now, if I was to go ahead and change something here, maybe I was to say, I could change this to maybe 3, and I could run this, and then I'm going to get an error when I have my test because, again, I'm not getting the correct solution. And this is a great way for instructors to be able to see that something is going awry with a student's work. So this is an important tool for those of us that have to spend a lot of time grading and get back to research. So that's something that I feel like is extremely valuable. And more so, being a recent graduate student myself, I have experienced long, cumbersome times of not receiving feedback from my instructors, which is, I have to say, frustrating. So especially when you have another assignment that's due and it's coming up and you don't know if you did the assignment before that's right. And we know in mathematics and computational science that things tend to be cumulative and they build on each other. So if you do the first step wrong, you're probably going to do the second step wrong. And one thing that NB Grader can do for you is it can provide students immediate feedback by having test cells. So here I'll go ahead and just quickly point out, I created a function f, and I wanted to test the Jacobian of some partial derivatives of that function f. So here I went ahead and did that. So if I was to run this, I would get my output. Says y is not defined. Oh, I didn't run this. So there we went ahead and outputted the Jacobian for our partial derivative of f with respect to x, and it gave me this output. And then as a student, I could go down here and I could actually test my function. And if something is awry, so we would immediately know that something's awry. And at that point, then I would be able to go back to my code and continue working and make sure that I can just go ahead and do these test cells. Now, one thing that I could quickly note about the test cells is that you can have additional instructor tests. That is something that I used up here, but you can have, and you can actually have, again, a hidden instructor test that has maybe more points that it's going to test throughout the function. Just to make sure that someone isn't just kind of, manipulating the system because they can actually see one of the outputs that are listed here. So I can't just design something that passes the test and then I get full points. But that's my little lightning spiel on Sagetech and on NB Grader using Sage. So now I'll go ahead and I'll pass the floor over to William.
I just said there was a question in the chat, but
Sure.
William seems that he answered it. Okay, so essentially the question was, which part of your preamble are the minimally required ones? And William answered, use package Sagetech.
Yeah, so yeah, if you wanted to implement the Sagetech file, all is what you would do. And actually, anytime that you open up a LaTeX document, it actually comes preloaded with the commands for that. Right here, if you can see that, enable Sagetech to run Sage math code right inside the LaTeX file, you just go ahead and uncomment those. And then you can immediately start running the code and you don't have to do any extra loading of packages other than that.
So I'm just starting from scratch running Sagetech. And by default, it automatically runs Sagetech whenever you save the file. /sage back to 2020.
And that again is an example of running the code inline.
That doesn't look right. Ah, there it is. Okay, now factored. I think it was running the version before I typed it. Okay. Right, so are there any other questions for Blake?
Yeah, you guys are very welcome.
And I guess the other thing to say about Sagetech is, of course, it was written initially at Sage Days 1 by Joe Weatherall and David Rowe, and it's available, of course, everywhere, not just in CoCalc. You can easily use it in Sage anywhere. You just have to have the right style files and things put in the right places. And it just happens that in CoCalc, we make sure everything is pre-installed. So you can just trivially start using it immediately without having to set anything up. There's also a package called Python Tech, which is very similar to Sagetech, but for the more general Python ecosystem. Okay, so I'll start my talk now, which is right here. I'm going to try to keep it to 8 minutes. in that a big timer is going to pop up when I'm done, when I reach 8 minutes. Okay, so I'm going to talk about different ways of, additional ways of using Sage and CoCalc. So one is via Jupyter Notebooks and things in the Jupyter Notebook ecosystem. Another is just by creating files on the file system and then editing them and importing the Sage library. And a third is by self-hosting CoCalc. So those are 3 topics I'll cover in my few minutes. So first, you can use Sage via various Jupyter Notebook environments in CoCalc. So if you just, if you're using CoCalc, you can easily run using the same files that you have in a CoCalc project, a Jupyter Lab server, a Jupyter Classic server, or a Visual Studio Code server. These are all just integrated with CoCalc and easily run. And the way you do that is just click New, and then choose which of the servers you want to run. So if you want to run Jupyter Classic, you click this button, it fires up a copy of Jupyter Classic, and there it is. You can go around and just start opening files and browsing and generally using Jupyter Classic. Similar with Jupyter Lab, we have Jupyter Lab available. You just click, boom, you're using the same files as your CoCalc project, but from Jupyter Lab, which has things like a nice launcher, has a whole bunch of Sage kernels pre-installed and other kernels, etc. And here's a file where I did something. So you can also run VS Code server. And by the way, with Jupyter Lab, we do now enable real-time collaboration by default. So you can have multiple people editing the same file in Jupyter Lab collaboratively, and that should work. And then finally, we have VS Code server. So VS Code has Jupyter Notebooks integrated with it now. You can also edit Python files, as you can see here, and it gives you lots of extra information about the file. I have to admit that I haven't done much in terms of getting Sage to work nicely with VS Code. For example, when you go to make a new Jupyter notebook, it gives a list of options for the kernel somewhere, and none of them are Sage, even though we have that kernel installed. So it just shows a couple of other, I don't know why it's not finding the Sage kernels, but that's something to be sorted out. But you can see at least how Python kernels work. So I'll choose this one. So this is Jupyter via VS Code running in a web browser from my CoCalc project. And there you can see it worked. There's also a Pluto server. This is a Julia notebook, which we also support, but Julia and Sage are, I guess, kind of competitors rather than, you wouldn't use Sage from Julia so much as Julia is trying to be similar to Sage, but with a just-in-time compiler and a much smaller ecosystem, because we have all of Python, but a much faster compiler. Okay, so another way of using Jupyter Notebooks in CoCalc is that we have our own implementation from scratch that I wrote of Jupyter Notebooks. There are a number of things missing from Jupyter that bugged me for a long time. So that were in the Sage notebook. And so I ended up implementing from scratch my own Jupyter Notebooks. And let me show you that really quickly. So I'll just go make a directory demo 2. Whoops, make a directory .ipynb. So in that directory, I just made a new CoCalc Jupyter notebook. And here you can choose a kernel. There's some suggested ones. There's some nice sort of organized matrix that Harold Chile wrote that gives you a kind of a more structured way to choose a kernel. You can also just choose a kernel from this drop-down list. And if you want to add your own kernel in CoCalc, it's just like anywhere else, but we have a link that at least makes it really easy to find out how to do it. You click there, it gives you the directions specifically in CoCalc. Now let's learn something important about our future, namely, here are the factorizations of all of the upcoming years. So it takes a little while for Sage to start, but in a moment, it's going to output these factorizations. So you can see that we don't get another prime year for quite a while. So, but if you're doing funny number theory problems, it's always really important to know the factorization of the current year. So the Jupyter notebook in CoCalc has a couple of extra features or different features to the normal Jupyter notebooks, which I've shown you above. So for example, you can split the screen and view multiple points in your document simultaneously, kind of like in Emacs or a lot of other editors. You can, so like in the Sage notebook, you can make a WYSIWYG editable cell between the code cells. So this is a demo, and you can do things like math typesetting in that cell. So you can see how I can click and edit. Oops, I'll see a little preview in real time. And it's basically rich text editing. So you can do things like little bulleted list. And you can also do fun things with fonts, like go and use Comic Sans Microsoft and make it a silly color, that sort of thing. Under the hood, this is just Markdown, and you can switch back and forth between text and Markdown. But this is something that's just a little more friendly for students and so on. There's a time travel button. So by the way, this is something that the Sage notebook had that Jason Grout added like in 2009, which is what you see is what you get editing of what's between cells. But then Jupyter officially you lose. So I remember when we were switching from Sage Notebook to Jupyter as the default environment in Sage, there's a big list of things that you lose by switching to Jupyter. I've been trying to push for official Jupyter to have all these things, but it's taking forever. There's a time travel slider, so this lets you go back and forth in time and see exactly how the document was created. And you can also click a changes button and see exactly what changes between 2 points in time, which is nice. So you can see how something got to be a certain way. You also see a name associated who made the change. There's some other features, so you can see the underlying JSON view of the document. So this is the underlying JavaScript object that defines the notebook. You can also view an editable version of that, which could be kind of fun. Suppose you're very unhappy with the factorization of 2020, you can change it. And you'll see that when I save, it gets updated in the output. So it's kind of evil. See, now 2022 is incorrectly factored in this list because I directly edited the underlying code. Some other things you can do, you can click on console, and this gives you a command line, a full Xterm color, like with Vim, it does full terminal stuff, but it's connected to the same Jupyter kernel as what I'm using over here. So for example, if I type n, it's going to give me the last value of n from that loop. And I could do something like f of x equals x cubed plus 1, or sorry, plus 1 if I wanted, and then I can go over here and do plot f. So if you want to make really confusing Jupyter notebooks that are not only nonlinear, but with code that you can't even see, you now have that option over here. And there's a lot of other things. There's chat on the side. So you can have a chat room, everybody. And you can publicly share your notebook. So you go to File, Public, and you say click Public, and then there's a link to the notebook, which is now publicly visible to anybody on the internet, which was another feature we had in Sage Notebook that kind of disappeared from Jupyter, which is the ability to easily just publicly share things. And there's a lot of other things, like in the Sage Notebook, like Mathematica, you could click on a little blue line between cells to add new cells, which is a nice little thing to do. Okay, so that's CoCalc's Jupyter Notebook. Oh, one other thing that Harold wrote, which is snippets. So if you go right here and click on snippets, you get these really cool, just this massive list of examples of how to do things in Sage. Like, oh, I want to show off a 3D plot that's say an implicit plot. So you just do that, insert the code, and then over here, wherever your cursor was, you see the code and it ran. You get your nice 3D plot. Okay, another way to use Jupyter inside of CoCalc is via, I'm already out of time, so I'll be very quick now. Another way to use Jupyter inside of CoCalc is via whiteboard. So you just do plus new, make a whiteboard, and you just get like a blank infinite canvas where you can make little sticky notes that have math typesetting in them. You can scribble with a pen if you want. But most importantly, you can use Sage. So you can do, I'll just plot an icosahedron. And you can make lots of code that does stuff. So as soon as the kernel starts in a second, you'll see an icosahedron here in, you click there. So here's an icosahedron. And on the right, it has a nice little organized view of all the things you've typed in. So you can quickly just click and it centers that thing where you can search and find it. So if you want to combine kind of a whiteboard view and make a little note next to something you're doing and not have to worry about things being in a linear order, you get that option. And there is an underlying Jupyter notebook. You can just click and see the actual corresponding Jupyter notebook where all the code is being run. Okay, so that's that slide. And the other two things, I wanted to mention that you can edit Python code from within CoCalc, very much like how you'd edit code in, on your laptop. And then you can import it or run it in however you want. So just really quickly, here's foo.py. So this is just a normal Python file. And I could do from sage.all import factor. And then I could do something like print factor 2022. And I can go here, make a terminal, and then type Python, or actually type, sage foo.py. And now it'll run that file. You can similarly edit .sage code, and it has syntax highlighting, code folding, all that kind of stuff, and time travel, collaboration, everything like before. And when you're browsing around in the terminal, you can also easily open code using the open command. And one fun thing you can do in your web browser is turtle graphics, which use X11. So you can write, you can use X11 type graphics directly in a web browser from within Sage. And there's also lots of other actual X11 programs you can use as listed below. So here I'm starting with Sage. I'm hopefully running that example from the official Python documentation. And in a moment, it will appear right here. I think it's taking a second to start the X11 server. And I just used up all the memory in this project. So, I guess I'll skip that example, but it would pop up. Oh, looks like it's going to appear. There it is. So now turtle graphics are drawing in the browser, which is nice because you could change the zoom level. It's something that is often requested to be able to use these old traditional programs in your web browser, like Python's idle or Emacs or whatever. And you can see that, like, I'm using Emacs, I'm using Python's idle shell, etc., all in my web browser, which is kind of cool to be able to do that, and turtle graphics from Sage. Okay, and then the final thing I want to mention, which is very important, you can run CoCalc easily right now on your own laptop using CoCalc Docker. And this is totally free to be able to run it. And this is literally all you'd have to type, assuming you have Docker installed on your computer, to download and run CoCalc Docker. So this banner, by the way, is telling me that so we've been running a huge amount of things in this project for our demos, and then we're running out of memory. And that's what it's saying. It includes Sage 9.6, this CoCalc Docker. There's also a very, very minimal version if you do CoCalc Lite, but doesn't include Sage. So you'd have to build and install Sage yourself. And one very important final thing, there's a server running at University of Washington that was provided by a grant. It's running CoCalc Docker, and it has 256 gigabytes of RAM and 48 very fast CPUs. And it's supposed to be for random stuff involving Sage development. So if you want to do Sage development in CoCalc and want a very powerful computer, play around with things involving Sage development, ask me and I can make an account for you on this server. And just to end my talk by showing you that it's very powerful, I'll make a terminal and type top and then type 1. And you can see that there's a very large number of CPUs there. And also the memory is really, really big. So if you contact me, I can give Sage developers an account on there. It's a handy resource. If you just want to, be able to build Sage very quickly or collaboratively edit code with somebody else. Okay, and now I am done. Thank you. Any quick questions before we move on to Harold's talk?
If you've made a CoCalc Jupyter notebook, can you export it and someone can read it into an ordinary Jupyter?
Absolutely. So CoCalc's format is exactly the same with no changes to standard Jupyter. And all the other extra stuff we add is basically usability. We don't change anything at all about the file format.
Good,
internally, we do use a different file format, but every time you save to disk, it exports to IPyMB format. And anytime you change the IPyMB, it imports back. So we have no custom extensions to the format at all, and everything 100% should work. And if it doesn't, it's a bug that we want to know about.
I had a question about exactly what you mentioned at the end. So let's say,
Yes.
so a few years ago, there was this project, it was Horizon 2020, about like, that helped Sage a lot. And among the projects, there was this binder project that someone, let's say, could develop a package, and along with a paper that they developed, they can provide notebooks that they can try out with code. So I was wondering, let's say maybe an update on that. So because I tried
that's a good
recently, and I was wondering, is there an opportunity for this in CoCalc?
Yes, and that's a really good segue into Harold's talk, because Harold literally spent like 2 months or so, 2 years ago, implementing that same functionality in CoCalc. So he can give an update about that maybe for a second. Harold, do you want to take over? Because you're right there.
Okay, perfect. So update. Well, so all that this binder does is you have a directory, okay, and it defines how software is packaged up in a Docker image, okay? And what CoCalc can do is deploy this image on our internal server and use it as the underlying base to run a CoCalc project. So the big difference is that my binder, as a service that provides these binder images, is not stateful, but CoCalc projects, they are stateful. So there are a few different things that need to be, someone needs to be aware of, like files could get overwritten, or you could overwrite them by reinitializing the parts that should go in the same home directory. And of course, a lot of functionality is lost if it is not installed. Okay, does this help?
Yeah.
If you have a specific use case in mind, we can certainly set this up on CoCalc, especially if it is useful for teaching. And we did this in the past several times.
Perfect. I'll let you know about this.
Yeah,
project.
it's not for self-serving purposes. And the other aspect is primarily we try to install everything you want in Sage directly in the Sage install. So we have several versions of Sage available, and all of them are maybe 2 or 3 times as large as a default Sage installation, just because there are more packages. Like these optional packages, there are a lot of them we just throw in, and also Python packages to supplement a lot of functionality. Okay. About my talk. So I think one and a half weeks ago, there was just a mention about using R Markdown on CoCalc to run Sage. And my first thought was, hey, this is just for R and this won't work. But there is a package that connects from the R world to Python. And if you have a Python interpreter, then you can make use of it. So what's going on? So R Markdown, if you haven't heard of it, this is a slightly enhanced plain text Markdown file. It has a preamble in YAML, and then you process this document first. It is ran through Knitr, which is an R tool that understands the code blocks in your document and runs them using R. And then it uses Pandoc to convert the processed Markdown into HTML or PDF. And what you see here is a PDF Beamer presentation using some styling that was generated on CoCalc using R, and R is calling the Python instance in Sage. Okay, and just to mention on the side, there is also Bookdown, which is an enhancement of R Markdown, where you can write all sorts of complex documents, like it produces then all the websites with an index to browse through and so on. Okay, so this is R Markdown from the world of statistics. And here is the connection to Sage. So the package in R that makes this bridge to Python is called Reticulate. And this is the code to set it up. So you load it, and then you say, okay, use the Python instance that's defined here. This is my Python 3 inside of Sage. Okay, and then we can check, is this actually working? Well, what's the executable? Sure enough, it points to the Python 3 instance inside of our globally installed Sage 9.6. What's the version? 3.10. And somewhere in the path, yes, there are those side packages. So, okay, the basics are there. Can we work with the Python instance directly? So yes, we can load NumPy, we can load matplotlib, we can create some vectors. Okay, there are numbers. And once we have numbers and it looks something like a nice function, can we also plot it? The answer is yes. We create a figure of a certain size. And then, okay, this is standard matplotlib, and we create the result. Okay, cool. So where is Sage? So the next step is, let's try and load everything, load all of Sage. So at least now it's possible to plot the version number. And beyond that, it's like, okay, those are the limits of R Markdown in connection with what Sage can do. And if someone is interested in enhancing this, well, I think there are a lot of low-hanging fruits. So the first thing to look into is calculus. I want to differentiate or integrate a function. I can type it in standard Python notation, and I get standard Python formula as a result. To make this look better, I can use the LaTeX function and get some text result of the LaTeX command, and then I can use reticulate to access the variable x1 that I've defined here in Python, which is a string, to convert it to R. And inside of R, I can say, okay, insert this inside of dollar signs to actually create the formula. So yes, here's the formula. This also works for matrices. Like I can write Sage code here. Then hidden in a little cell, there is the conversion that's going on to the LaTeX snippets. And below here is the output. Then plotting. Well, my naive way to plot is just to say, okay, show P, but what it tells me is just a text representation of the graphics. Or maybe there's a way to expose the underlying matplotlib object directly, and then it would be picked up, but I don't know how to do this. My way to show a graph is to just save it as an image, and then here is a figure with a subtitle, and I can define that this is aligned in the middle and with a certain width. Okay, and what's the conclusion of this? So I think the overall benefit of knowing that R Markdown exists is that there is a large ecosystem. You could create presentations, PDFs, books. You can so basically you can control almost all aspects of your LaTeX pipeline. And on the other hand, if your output is HTML, there are ways to do HTML presentations, websites, and using Bookdown, write whole books that you can browse easily. And what's the role of CoCalc? Well, everything is pre-installed and ready to use. And just to show you how this looks like, on the left-hand side, here is the plain text R Markdown file. This is the preamble, and this is like the definition for the presentation. And here's my name and title. And on the right-hand side, I can browse through the document. And every time I do a modification on the left-hand side and save it, then the build process is started. Yeah, and this is how I did this plotting, like include false. So here's a code block that's run in Python and giving me the LaTeX representation. And then here is the result I'm just inserting as it is. Okay. Are there any questions? Because I think those were my 5 minutes. I can also show you I did the same for HTML. So if I click here for the HTML part, I get the website also embedded here, and it's basically the same content, just rendered through a different pipeline. Yeah.
This is basically going to be my origin story about how I got interested in Sage Math and came to be an employee of Sage Math Incorporated, working on CoCalc. I'm an operations officer. I do documentation support and a lot of office functions relating to quotes and so on. So, but the goal of this talk is to show, highlight a few basic features of Sage Worksheets that made a dramatic difference in my personal studying efficiency and overall sense of accomplishment. William, can you show the Sage Worksheet? Thank you.
Okay, thanks.
All right, so I discovered Sage Worksheets, which are a feature of CoCalc, many decades after my college days. I was taking online courses, undergraduate physics, and I wanted to reduce the number of errors and improve the clarity in my numeric and symbolic calculations. So I'm just going to do a quick view of three very basic features of Sage in Sage Worksheets that made life easier for me as a undergraduate level student. And these are LaTeX, symbolic expressions, and units of measurement. And for LaTeX, the difference is I was already aware of LaTeX as like a separate stage. After you've done all the math and you want to clean it up for publication in a PDF, as a separate stage. But with Sage Worksheets, I could do a LaTeX every step of the way. So it became an integral part of my thought process. And that helped a lot. So the standard opening for my physics Sage Worksheet files became what you see in the top cell there. %auto means run this cell whenever you start the Sage Worksheet, and then typeset mode true means display the output in LaTeX typesetting. So then the other two features that I'm going to go into are symbolic expressions. And the examples here are all very basic. Many of you could probably do all of these calculations in your head. But imagine, first of all, that you're an undergraduate student just learning things. So your processing speed is not quite that of a career mathematician. And also that the typesetting helps clean up what would have been a mess on scratch paper. So the first example uses symbolic expressions to follow the motivation of the Schrödinger equation, a very simple form of it, starting with the Helmholtz wave equation. So basically, the details of what's going on with the physics aren't relevant as much as what I want to show you how I use these manipulations. And imagine these equations with a dozen or so additional terms and variables and constants, and how easy it would be, especially for someone as a student, to lose a minus sign or drop a term and end up with a completely wrong result. So these substitutions in a Sage worksheet allow me to do two things. I can use them initially to get to the desired answer. I can use them to check my work to make sure that what I have on paper agrees with what the computer says it should be. So just to go through a few parts of this calculation in line 28, you see definition of a symbolic expression E0, where we're defining this Helmholtz wave equation as a differential equation. And then on line 31, we're defining what it is to be a wave number for a function. And by the way, I don't know if you've ever tried to define a Python variable lambda, but it's not an easy thing to do, so because lambda is a reserved word in Python. Okay, so then go on with more definitions, defining E2 for the de Broglie hypothesis, and line 45, the reduced Planck constant is the Planck constant over 2 pi. So far we've just been setting up our definitions, and now the manipulations start at line 49, where basically what I'm saying is I can take my symbolic expression E1 and substitute symbolic expression E2, and then in that substitute E3 solved for H. And the result I get is a rearrangement of terms that's necessary to go on with the calculation. So, and then in 52, we do another substitution And on line 57, we define a symbolic expression for what form of Newtonian kinetic energy. And then finally, the coup de grace is line 61, where we arrive at a simplified form of the Schrödinger equation. So that's an example of using symbolic expressions in Sage to check your work as you're going through calculations. The second, or the third feature I want to talk about that I don't hear a lot, haven't heard a lot about in the discussion group, so although I haven't been on them lately, is units of measurement. Now, I'm aware that there are many different units of measurement in the Python and Sage ecosystems. This is the first one I found, and I still have a warm place in my heart for it. I know that SymPy and AstroPy have some more very sophisticated units of measurement systems as well. So in this example, I'm just going to calculate the ground state energy of an electron in a one-dimensional potential well. And we start with a basic Sage function on line 84. You give it the energy level 1, 2, 3, 4, and so on, and it returns a symbolic expression. And what we're going to compute the ground state energy, so we just are interested in E with n equals 1, and the output on line 90 shows what that expression is. Then a standard part of my physics studies was to include a whole bunch of constants. And William, I don't know if you want to show the physconst.sage, but this is an example of loading a Sage file from a Sage worksheet. The working version of this file was much longer, showing importing many more physical constants. But the idea is that this includes the numeric form of a constant with units of measurement. So yes, for example, if you go down to the Planck constant on line 35 and 36, we want to give both the numeric value and the units of measurement. So now we can go back to the worksheet for going through the final part of the example. Is we load that, so we've now got numeric with units versions of h bar and the mass of the electron. And at line 100, we plug in, we substitute those values. And from the symbolic expression that was produced with the function e of 1, we now have this beautiful number, 6.10 about times 10 to the minus 39, with the units all divided by the square of the length of the potential well. And then on 104, you use a utility function that goes through a symbolic expression and expands every instance of pi that it finds into the numeric value of pi. And then the final step here is we are going to use, for this particular exercise, the width of the potential well is 1 nanometer. And we show that as width is on line 110, 1 times units length meter, and units SI, System International prefix is nano. And we do this substitution, and we get that beautiful numeric answer. But it's a lot of different units, and we want to rearrange that. Is that units of energy? And you might recognize that it is. But we can also just tell Sage units of measurement in line 115, convert this, and it would give me an error if my result was not, if I got meters instead of something that was energy, this would not succeed, but it does, and it says the answer is 0.37 electron volts. So to me, this was a real eye-opening experience, and it made studying a much more rewarding and joyous experience. I say in my notes that the symbolic expressions and units of measurement saved many trees, and my house was no longer a sea of scratch paper on weekends. So that's the end of my talk, and thank you.
Thanks. So there are questions for Hal? I put a question in, which is, what's a Sage worksheet versus a Jupyter notebook?
I actually had an answer to that in my initial version of talk, but I thought everybody would know. But, okay, so a Sage worksheet is like a Jupyter notebook in that it intersperses document cells, which are marked down typically, and computation cells, which are typically Sage, but can be in other languages as well. But there's a different feel to it that I actually prefer, having started in that environment, in that you don't have to stop your thinking to insert cells. It's not cell-based. In fact, this entire document is one instance of CodeMirror. Is that right, William?
Yes. And notice how I
So-
can make a selection that starts in the middle of one cell and goes into the middle of another cell, which is something you can't do with the Jupyter Notebook. So it's really just
for
one
me-
long single text
Yeah,
document.
for me, it's a smoother experience. I'm working with a single document rather than lots of little ones. But it's a
And-
very similar experience.
What another thing you might have noticed when Hal was talking through his demos, he could tell you the global line number for any input or output. And that's something you can't do in Jupyter Notebooks at all. But there's in the far left gutter, there's the global line number, and then there's a local line number for each cell. So you have both of those. The history of Sage Worksheets is I wrote them and I designed this in 2013 at the same time that Jupyter was first starting. And I just was trying to rethink the whole notebook approach. And this is what I came up with. But it's sort of like a different branch of development. And I plan to make it an alternative view of normal Jupyter notebooks because there's an isomorphism back and forth. So it should just be a different view of a normal Jupyter notebook. But I haven't done the work to unify these two in practice.
Okay, so
Okay,
perhaps-
we're done.
Yes, thank you very much, William, Al, Blake, and Harald for this really wonderful talk about like the broad and really rich ways to use Sage and CoCalc.